Hello friends, today we are performing the dissolved oxygen present in the water sample, okay, or the amount of the dissolved oxygen present in the water sample. So very first, the title of this experiment, determination of dissolved oxygen present in the given water sample, okay. So then what are the instruments required for this particular experiment? The instruments are burette, pipette, conical flask, measuring cylinder. Okay, so these instruments are required because this is the titration based experiment. So this particular experiment we required the all these glasswares. Then chemicals, the chemicals are required. So very first chemicals is required MnSO4 manganese sulfate, then alkali iodide hazard, then concentrated H2SO4 and starch indicator, and sodium thiosulfate as a titrant. 0.025 normality sodium thiosulfate we are using the as a titrant. Okay, so just start, what is the principle? So very first, whatever the oxygen or the maximum amount of saturated oxygen which is present at 0 degree Celsius in the water is 14.2 mg per liter. At 0 degree Celsius, the saturation of saturated oxygen present in the water is 14.2 mg per liter. So at the natural condition or normal condition, the amount of the oxygen is vary with the temperature. So whatever the water sample you are collected from your different water sources, so the amount of the oxygen is also differ. The water sample which is collected from a wastewater area or wastewater source, so oxygen concentration or dissolved oxygen concentration is very less, or sometimes it is nil, or sometimes it is not present. The sometimes the dissolved oxygen concentration is not present in the wastewater. So this DO is very important for biological treatment or for biological activity, because by using this molecular oxygen, the microorganisms are oxidize the organic matter which is present inside the wastewater, or by using this oxygen, dissolved oxygen, microorganisms are oxidize the carbogenous organic matter to nitrogenous organic matter. So for this biological activity, the dissolved oxygen concentration is very important. So that's why we are performing this experiment, determination of dissolved oxygen concentration into the water. So what are the procedure? So just see what is the procedure. First, we have to take the water sample in the closed container. This is a BOD tube, BOD bottle, 300 ml BOD bottle. Okay, we use this bottle for the water sampling, and this bottle is a special bottle because in this bottle a cap is provided. So for avoiding the atmospheric gases contamination after filling this to this water, this cap is provided, avoiding the atmospheric gases contamination, because if suppose there is the if the DO concentration is absent in this particular water sample, and we keep this open, bottom mouth is open, then what happens? Some atmospheric gases or atmospheric oxygen is tried to diffuse inside this wastewater. Okay, so avoiding such condition or to get the accurate reading, we have to place this cap on the top of this bottle. Okay, then we have to first fill this BOD bottle with 300 ml water sample. Sample you should be collect by the grab sampling or composite sampling method. By any method you can take the wastewater sample. Just fill this wastewater in this BOD bottle. Then add 2 ml of manganese sulfate. Add 2 ml of MnSO4 very first into this BOD bottle. So we are adding the manganese sulfate two ml of manganese sulfate into the BOD bottle. Into this bottle. Then we are adding 2 ml of alkali iodide hazard. We are adding 2 ml of alkali iodide hazard to water sample. This will be formed brown color. This will be formed brown color. So this brown color is represented the dissolved oxygen is present into the water sample. If this color is white color, it means the dissolved oxygen is absent from this water sample. Okay. So after the adding manganese sulfate and alkali iodide hazard, so this solution will get the brown color, brown precipitation in form, and we have to wait the settle down this brown precipitation at the bottom. Then next step we have to add 2 ml of H2SO4, concentrated H2SO4 into this solution. 2 ml of concentrated H2SO4. After adding H2SO4, this precipitation is disappear. Precipitation is disappear, and we have to shake it properly, very well, and you will be able to see whatever the precipitation is formed, they will be disappear, and this water will be clear orange water. Okay. Then we have to take 203 ml of water sample for titration. We have to take 203 ml of water sample for titration in conical flasks by adding starch indicator. After adding the starch indicator in this particular sample, its color become blue. So 1 minute. So we are adding this water sample into the conical flasks, and we will be adding the starch indicator. Into this water sample.